completed accuracy, what is the resolution of the instrument, and after that precision, and completed successfully linearity. Now we'll go for a sensitivity. One more characteristics, that is called sensitivity. So sensitivity means the person is more sensitive, means for a small things also he is reacted. For a small changes the instrument will react. So that is more sensitive instruments, right? So those type of instrument we require, because each and every climatic condition, each and every simple conditions also my instruments will read. Then only you'll know how much error that can be present in the system. It can be easy. So sensitivity means the smallest change in the output divided by change in the input, we can call it as a sensitivity. So what is a sensitivity? Change in output by change in input, we can call it as a sensitivity. So delta output, change in output by delta input, change in input, we can call it as a sensitivity. So definitely the instruments which is having high sensitivity only you can prefer. So that means you can easily get the how much error that can be present in the system, right? In following classes, we'll discuss what is a deflection factor. Deflection factor means how my pointer will start a deflection. We'll use a deflection factor. So that deflection factor we can easily calculate from the sensitivity. So the deflection factor is equal to 1 by sensitivity. This is one more important point. Alright, this is important point. So deflection factor is equal to 1 by sensitivity. Now, and one more important gate question is, if a torque to weight ratio, this directly you can note it down. If a torque to weight ratio increases, my sensitivity also increases. These two are very important gate questions. In a last year gate also you got this question. If a torque to weight ratio increases, what about the sensitivity? If a torque to weight ratio increases, my sensitivity also increases. But suppose if I having different types of instrument, how you can calculate the overall sensitivity of the instrument? I have the instrument S1, right? So I have the instrument S1, given input is Xi, output is X1, input is Xi, output is X1, and that X1 is input to the second instrument, I'll get the X2 output. That X2 is input to the third instrument, I'll get the X0, right? So what is the sensitivity of the first input, output by input? So Xi by Xi. So X1 by Xi. What is S2? X2 by Xi. What is S3? X0 by X2. Then overall sensitivity. So overall sensitivity means total output by input. What is output? This is my output X0. What is the input? X1. Right? What is X0 by Xi? We can call it as the overall sensitivity of the instruments. How you can calculate S1 into S2 into S3. So then we can call it as, then we will get X0 by Xi. Total sensitivity of overall instrument you can calculate it by product of each and every instrument యొక్క sensitivity. So total overall sensitivity is equal to S1, S2, S3. The product of S1 and S2, S3. This is very important note. Right? So what is the sensitivity? Change in output by change in input. We can call it as a sensitivity of the instrument. Definitely you require high sensitivity instrument should prefer in each and every unknown quantity calculations, right? So that's about a sensitivity. Then we'll go for a repeatability and reproducibility, right? See, this is very important. I'll clearly explain. What is a repeatability, right? See, you don't go for any definition and all these things. You just follow my voice. So with that you can clearly define yourself. That's a definition. Writing something definition is very difficult to understand. So follow my voice. So with that you can define yourself for each and every definitions, right? So what is a repeatability, right? One experiment done by one user, right? One experiment done by one user with one instrument, right? For the same input, right? And at same time, same input, same time, will get the same result. See, one experiment, one user, same input, same conditions, we'll get the same result. See, for example, my input is 5 volts, నాకు 5 volts కావాలి. సో ఐ హ్యావ్ ఎన్ ఇన్స్ట్రుమెంట్ 0 to 10 volts ఇన్స్ట్రుమెంట్. సేమ్ కండిషన్, ఒక ఒక రూమ్లోనే నేను చేస్తున్నాను, సేమ్ కండిషన్లోనే నేను చేస్తున్నాను ఎక్స్పెరిమెంట్ని, రైట్. సేమ్ ఇన్పుట్, నేను మాత్రమే చేస్తున్నా. వన్ యూజర్, వన్ ఇన్స్ట్రుమెంట్, సేమ్ కండిషన్, సేమ్ ఇన్పుట్, రైట్. వన్ కండిషన్, సేమ్ కండిషన్లోనే ఎక్స్పెరిమెంట్ చేస్తున్నాను. ఐఎమ్ గెట్టింగ్ ద రిజల్ట్, సేమ్ రిజల్ట్. ఫర్ సపోజ్ 5 volts కావాలని నేను 0 to 10 volts వోల్ట్మీటర్ తీసుకున్నా, రైట్. ఒక రూమ్లో కూర్చున్నా, సేమ్ కండిషన్, ఫస్ట్ ఎక్స్పెరిమెంట్ చేసా, ఐల్ గెట్ ద 2 volts. కొద్దిసేపు ఆగి మళ్ళీ ఎక్స్పెరిమెంట్ చేసా, ఐల్ గెట్ ద 2 volts. And some other time you'll get the same result, 2 volts, 2 volts. So that is called a repeatability of the instrument. Only one user, నేను మాత్రమే చేస్తున్నాను, సేమ్ ఎక్స్పెరిమెంట్, సేమ్ వోల్ట్మీటర్, సేమ్ ఇన్పుట్, సేమ్ కండిషన్, ఐల్ గెట్ ద సేమ్ రిజల్ట్, రైట్. సి, నేను మాత్రమే ఓన్లీ వన్ ఎక్స్పెరిమెంట్, వన్ యూజర్, రైట్. సేమ్ కండిషన్, సేమ్ ఇన్స్ట్రుమెంట్, రైట్. సేమ్ ఇన్పుట్, you'll get the same results, right. 5 volts కావాలని వెళ్ళాను, కండిషన్లో ఎక్స్పెరిమెంట్ చేసా, ఐల్ గెట్ 2 volts, 2 volts, 2 volts, 2 volts ఈచ్ అండ్ ఎవ్రీ టైమ్. ఆ రూమ్లో కూర్చొని చేసి ఈచ్ అండ్ ఎవ్రీ టైమ్ నాకు 2 volts, 2 volts, 2 volts. దట్ ఈస్ కాల్డ్ అ రిపీటబిలిటీ. నౌ వాట్ ఈస్ అ రీప్రొడ్యూసబిలిటీ, రైట్. వన్ ఎక్స్పెరిమెంట్, డిఫరెంట్ యూజర్, different conditions, different instrument, but you'll get the same results. See, one experiment, different user, different instrument, different conditions, same input, you'll get the same results, right. నేను 5 volts, నాతో పాటు 10 మంది ఉన్నారు, 10 మంది ఎక్కడెక్కడ ఉన్నారు. నేను 5 volts కావాలంటే 0 to 10 volts ఇన్స్ట్రుమెంట్స్ తీసుకున్నా. అతను ఎక్కడెక్కడో ఉన్నాడు, అతను కూడా 0 to 10 volts ఇన్స్ట్రుమెంట్ తీసుకున్నాడు. నేను కండిషన్ స్టార్ట్ చేశా, ఐల్ గెట్ ద రిజల్ట్ యాజ్ 2 volts. అతను అక్కడ చేశాడు, డిఫరెంట్ కండిషన్లో ఉన్నాడు, రైట్. సేమ్ ఇన్పుట్, 5 volts మే ఇన్పుట్. ఎంత వచ్చింది అతనికి? 2 volts. ఇంకొక అతనికి 2 volts. ఎస్. సో దట్ మీన్స్ దట్ ఈస్ కాల్డ్ అ రీప్రొడ్యూసబిలిటీ. దట్ మీన్స్ వన్ ఎక్స్పెరిమెంట్, different users, different conditions, different instrument, same input, you'll get the same results. So that is called a repeatability. See, 5 volts ఒకరు చేస్తే 2 volts వచ్చింది, ఇంకొకటి ఎక్కడో ఉండి చేస్తే 2 volts వచ్చింది. That's about reproducibility. You'll get in a precision, right. So what is the repeatability and reproducibility? So repeatability means one experiment done by one user, same condition, for the same input, same instrument, they'll get the same result. What is meant by reproducibility? One experiment done by different users with different instrument, with different condition, for the same input, you'll get the same results. So that is called a reproducibility. Right. And the last desirable characteristics is range or a span. So what is a range? A range means full scale. For suppose my scale range is meant, if you want to find out the range means minimum value to maximum value, right. Right. I'll clearly explain with example. For suppose the scale is like this, 0 and my full scale is 30. What is the range of this instrument? That means the minimum value to maximum value, we can call it as a range. So what is that range? 0 to 30. So what is the range? Range is 30. The full scale value, we can call it as a range. For suppose my scale is 0, 100. So what is the range of this one? 100. Full scale is, we can call it as a range of that instrument. Very, very important. Last Polytechnic College lectures also, you got these type of questions. What is the range and span of that instrument? He has given the scale, so with that you can find out the range and span, right. For a given scale, what is the range? Range is nothing but a full scale. Full scale, we can call it as what is the full scale here? 100. So 100 is my range. What is a span? Span represent maximum to minimum. So span represents the maximum to minimum. So that means span is equal to maximum. Span is equal to mod of maximum minus minimum. We can call it as a span. So maximum value to minimum value, we can call it as a span. Minimum value to maximum value, we can call it as a range. right? Now we'll discuss. I'll give one example, so with that you can clearly understand what is a range and what is a span, right? Here you will see my voltmeter reads 0 to 30 300 volts, right? My voltmeter reads 0 to 300 volts. What is the range? You will tell. The full scale we can call it as a range. So what this is called a range of that instrument. What is a span? Span means maximum to minimum. So mod of 300 minus 0, we can call it as a spam. So what is a spam? Spam also 300. So this is a problem. And one more problem is there. The thermistor measures the temperature of minus 20 degrees to 30 degrees. So what is the range? It's a somewhat difficult question. You will see what is the range here. Maximum and the 30 degrees. So this is the range value. What is a spam? Maximum minus minimum. What is the maximum? 30 minus minimum. What is the minimum? Minus 20, right? So don't forget to take minus in that. So what is that value? That is equal to 50 degrees centigrade is my spam. The last polytechnic lectures question. So that is about a spam. So that is about range and spam. Range is nothing but full scale value. Spam is nothing but maximum to minimum. Range means minimum to maximum. We can call it as a. So these are desirable characteristics. So what is a desirable characteristics? Means accuracy, precision, uh, resolution, linearity, repeatability or reproducibility, sensitivity, and last range, comma span. So these are desirable characteristics for each and every instrument. Thank you for now. So could you see the video one or two times? Definitely you'll grab the information. Right? This is very important question. For a, not only for your what you got board exams, definitely it will be used for your competitive exams also. Definitely in a gate you will get at least one question from the static characteristics. Dynamic characteristics we don't have that much important. So static characteristic, that too undesirable. In the next session we'll discuss about undesirable characteristics. So hysteresis, what is dead time, dead zone, threshold, and all these things, static error, and all these things we'll discuss in the next session. Okay, thank you.